So I'm going to talk about Lua, and as those of you who have come to SuriCons before probably know, I always talk about Lua. This is the first time I've managed to do it as an official talk at SuriCon. So, what is Lua? For those that you don't know, it's Portuguese for moon. It's a small, extensible language. I found this wonderful quote online when I was Googling about it. If you read, you'll see that the Lua team were very well aware of many developments in programming languages and were able to choose from among the best ideas. Most designers of popular scripting languages have been amateurs and have not been nearly so well informed. Lua is superbly designed so that the pieces fit together very nicely with an excellent power-to-rate ratio. Lua is superbly engineered. The implementation is just staggeringly good. I'm not actually an expert in programming languages, so I can't offer much of a comment over that. But yeah, it's a language that I've come across in other places. It's in Wireshark. They're using that now for adding protocol analyzers and detection. Lots and lots of games use it. There was a huge list on Wikipedia, so I just picked a few because one of the prime things that you need in a game, as in network detection, is it to be fast. People have told me of several others, and I mean, of course, it was mentioned this morning as for log processing and in the AI things that Randy was talking about. In Suricata, the support was actually added in September 2012, so it's been around for a while. Will Metcalf of Emerging Threats kept bugging Victor to put it in, and eventually Victor said, yes, we'll put it in. And then Will and I were playing with it pretty soon after that to do things like analyzing malicious Java files and so on. There was addition of the ability to generate your own log files using Lua in Suricata. That was added in March 2014, I think. You could actually modify flow vars, flow ints, and so on from 2013, but you couldn't really extract them into anything that, outside of other rules until December 2016. There's two variants. You have Lua, and then you have the just-in-time version of it. That one, the stable version of just-in-time compiler is actually version 2.05. It's been pretty much the same for several years. Ubuntu 16.04 long-term support edition uses 2.04. There's a development version 2.1 beta 3, but it's been that for 18 months at least. But they did include that in the latest Ubuntu LTS. So caveats you have to watch if you're going to use Lua JIT is that it's based on the older language spec for Lua 5.1. The latest Lua, I think, is 5.4. And there is, I'll mention later, a need to pre-allocate buffers in Suricata, or you might crash it if you're using Lua JIT. So probably best to stick to using Lua 5.1 features if you're going to expect to use the Lua JIT version. When you compile or configure Suricata and compile it, you have an option of enabling Lua or Lua JIT. You can only have one of them at a time. Myself, actually, I compile both and use one sometimes and one some of the other times. If you're going to use Lua JIT, there's an option in the Suricata YAML where you say how many memory buffers you need to pre-allocate because it has this strange requirement that they need to be within the first 2 gigabytes of memory. So what can you use it for? The first use really was detection, and I'm going to give an example, a piece of malware that has already been mentioned today actually, called Azervolt, which is a commodity stealer. It's sold on underground forums. We found a logo for it. The command and control traffic in Azervolt, certainly in the later versions, is obfuscated with an XOR algorithm. It's a little bit of an artificial example in the sense that actually there's only 2 different XOR keys I'm aware of at the moment, and you could have static rules to match them. But of course, there's always the possibility that we'll introduce another one, and it will be nice to be ready. We've got a few ET SIGs for them. That's just a handful of the ones that will match the latest versions. If you go into any.run, which is a fine place to find malware samples if you want to, that's what a screenshot of what I looked at last week, just to see how many samples they had tagged as a vault. And that's about 12 hours worth, I think, on that screen of samples that they saw. Some of them are going to be repeats. You first of all see it as the document and then the payload. But it's still, there's quite a lot of it out there. It's not the most prevalent one we see, but it is seen quite a lot. So what does the traffic look like? So a request for the initial command and control connection would look something like that thing at the top. And those of you that like looking for patterns will probably see that there's some regularity in it. It's a 3-byte XOR key. And if I decode with the right XOR key, then you see what I've got there at the bottom. But the problem is, it would be quite nice to be able to match that, but I can't match it statically because they decide to percent encode some of the characters in this long string and not others. And which ones they percent encode, they vary. So the most you could probably do with a static match is to come up with some sort of horrible PCRE expression. If I look at the response to that initial check-in, though, again, you might be able to see some sort of regularity at the start. If you decode it with this 3-byte key, you can see that there's a angle bracket, a C, close angle bracket, and then a base 64 string, and then another sort of closing tag. And that's something that we can certainly look for. So if I don't know what the 3-byte key is, then I can deduce it by just saying that I know the first 3 bytes are going to decode to angle bracket C, closed angle bracket. So here's a Lua script that will do that. There's some sort of setting up you have to do first with a Lua detection script. I'm interested in the response body in this particular case. When I write Lua scripts, I always tend to write a function that you can use to run Lua independently of Suricata. So that's what the run function is for. And then you can either decide to print something if it matches. It's a good way of profiling your Lua script first. And then we get to the actual meat of it. Assuming that the first clear text begins with this angle bracket C, then, well, I can just XOR with those bytes. That gets me the key. Then I can just try decoding the next 20 bytes, say, and seeing if I get a base 64 string out of it. And if I do, well, I've got the detection that will match any ASRock key that's using those 3 bytes. So here's a Suricata rule to do that. First of all, I need to have a static match. You always need with Lua. It's quite expensive to run it, so you don't want to run it on every packet or every HTTP connection. So first of all, I'm going to look for a post request that doesn't have a referrer, which is quite typical of ASRock. And if I see that, I'm going to set a flow bit that says I've seen this post with no referrer to a .php. And I don't have an alert, no alert on that. And then I have a second rule that checks for that flow bit, and if it finds it, and it's matching on the response, then you can run the script. And I can run the script manually, as I suggested there, with a command line. Yep, sure enough, if I pick a file that I've stored, that Suricata was captured, I can verify that it matches. But if I do a little bit more than just detection, if I go back to that base 64 encoded string, I could decode it, and actually you get something like this. It's telling me what files it's interested in stealing in this instance. A secondary download, because sometimes it's used as a downloader for more malware. And what we always seem to see is the victim IP and a locale for the victim. And wouldn't it be nice if I could store that stuff in Suricata logs automatically, because I know how to decode it? Well, there's 2 different ways we could do this. One is you can use a Lua output script, and to do that, it would look something like this. You have a setup function. You say, I'm going to store it in ASRock.log. It's quite nice to count the number of posts. And you have something that closes the log file at the end. Do some stuff to actually enable me to decode the base64 string. I actually cribbed that base64 routine originally from Black Hole Exploit Kit, which had done it in JavaScript, by the way, but it's a fairly routine way to do it. The beginning of it, well, one of the problems with using a Lua output script is it's going to run on everything. So you've got to do your own filtering first. So in this particular case, I'm just going to check it's a post request, that it's to something.php, and that it doesn't have a referrer. And if those conditions are met, then I'm going to grab the response body, glue it together, make sure it's big enough to be a plausible response body, and then the logic is the same as before. I'm going to log something that says I've seen something that I'm interested in and might be as a result. Do the detection as I did before, but instead of just returning one that it matched, I'm going to do some extra processing. I'm going to decode the next 768 bytes, in fact, or pick some value. I'm going to grab that request that I couldn't decode earlier, but it's available in the buffer. Often begins with 3 null bytes these days, so you can strip those off. And then you can decode it. You can write the key that we've managed to decode. You can then output all the base64 encoding. And finally, you can flush the file as before. And what's that going to look like? Well, then you have to enable the script within the outputs on suricata.yaml first. That's roughly where it goes. And this is an example output for well, the one I showed you earlier. I've obfuscated the stuff so that people don't start clicking on things and they see the PDF version of this. And you can see I've got the key logged there. I've got the request decoded there. I didn't bother decoding the percent encoding as well, but I could have done. And you can see that I've got the traffic I was interested there. They did the password stealing list and the secondary download and so on. There is a better way, though. And I think one of the problems with the output script, the output log way of doing it, is that this is running on every piece of traffic and was probably quite a performance hog. It could be useful if you're going to do post-processing of a PCAP, that kind of thing, where the speed isn't quite so important. But I think probably in live traffic you wouldn't want to do that. So this is the other way of doing it. Again, this is going back to that script I did for the detection, and all I've done to it is I've added rather more to the if there's a match. And in this particular case, I'm doing the same decoding as I did before, but I'm storing it in a flow var. And the result on that one, again, you need to make sure that metadata is getting logged in this particular case, evlog, but there are other outputs, Redis and so on, where you could enable metadata as well. And it would log into the evlog, that's the JSON that you get out of it. The same as before. I've had to hex escape stuff, but it's this stuff you can then have in a log processing system that could actually take out that information and correlate it with other things. There are some potential issues, though, with using Lua. This was a very simple example because it's just XOR, but sometimes you need to do, you might know how to decode some traffic, but it needs some cryptography. Or compression algorithms, zlib, or things like that. So RC4, yeah, that's quite easy to implement. XT is quite easy to implement. It's about a dozen lines each in most programming languages. But if I'm going to implement Serpent or AES or something like that, that's a lot harder. So questions for the floor really are, what can we assume is going to be installed on a Suricata system? I mean, if we assume that using something like Ubuntu LTS, then we could suggest maybe, well, if it's an available package in the Ubuntu distribution, then maybe it's not unreasonable to expect a user to install it. you do still need to tell the users which packages need to be installed. And under what circumstances will people be prepared to compile their own Lua libraries? You need to be careful about things like thread safety. The same script might be running in lots of different SuriCata threads at the same time. So if you're going to write to a log file, for instance, then you've got to make sure that you're not going to have several things trying to write to the same file. The Lua language, you probably saw from a little bit earlier, there are some weird things in it. One of my gotchas is I don't like counting from 1 in programming languages, especially when I'm trying to do modular arithmetic. But for some reason, Lua decides to count from 1. The regular expressions, those of us that are used to PCREs, which are horrible, I know, and there's lots of people hate them, but they are very powerful. They're rather more limited in Lua. If you're going to do some stuff, and I've hit this with linear congruential generators and things like that, you're doing large integer multiplication and so on like that. Well, actually, the arithmetic isn't necessarily going to be 32-bit or 64-bit safe. You might need an extra library to do the large integers, which if you were to use a scripting language like Python, you probably wouldn't. I'm very used to hex code escaping characters when they aren't ones you want to put there. You can't do that in a string in Lua in 5.1. You have to use a decimal code instead. 5.2, in fact, that you can put the hex ones in. So where can we use this kind of thing? My vision really is that there are lots of rules for traffic, for malware traffic, where we know how to decode that traffic. So it would be quite nice maybe to have exactly the same rules, so you're not changing the detection logic at all, but you're adding an extra script on the end that's going to extract more information. So this isn't going to cost you anything except maybe a little bit of memory, because you've already got a hit, but that you're going to get more useful stuff in the SuriCata logs. If you already have some Lua detection scripts, so it's easy to add this flowvar extraction stuff, as I just did in the example above. I also mentioned that you don't have to use Lua to store stuff in flowvars. If you can match it with a PCRE, then that's also a possibility. The Lua output thing, I think, is probably best used for automated analysis of PCAPs, or the result of a sandbox analysis, say. You could possibly use it to extract payloads that have been encrypted or obfuscated in some way and resubmit them to your sandbox, especially for the Windows executables. Other malware you can do scripts for. I've certainly done them for Formbook and LokiBot. With URSTIF, which is a banking Trojan, Formbook and LokiBots are both stealers, by the way. URSTIF, or ISFB, is a banking Trojan. That one encrypts its traffic using serpent keys in the URIs, certainly the earlier versions of that. But the number of serpent keys what we actually see is comparatively small, perhaps 20 maximum of them. So you could actually put them in your script and have it decode the traffic automatically. Danabot. Actually, I had a go at converting my Danabot script that I'd written in Python into Lua, and it almost works, but I'll keep you posted. Yeah. Danabot, by the way, was named after a sales engineer in the Proofpoint offices in Reading. She wanted malware named after her. Yeah, it uses raw TCP to port 443. So, but again, an AES encryption. So you can decode the traffic from a PCAP. There's that quote came from that Stack Overflow question. If you actually want to play around with the Azavolt PCAP I used, malwaretrafficanalysis.net, Brad Duncan's site, it's got loads and loads and loads of PCAPs if you ever want malware samples. Any.run is where I got that nice screenshot from of all the places. If you're interested in Azavolt, we blogged about it a couple of times, members of my team. Loads more blogs linked in if you go to the Malpedia article on it. I did a Google and found that somebody else was doing Lua output. It's not just me. Somebody at Trustwave Spider Labs was also talking about decoding Hansen malware with Lua scripts.